Okay, so like I said, today we are doing tangent lines and derivatives. By the end of today, you are going to be able to find the slope and equation of a tangent line to a given curve. Okay, so finding the slope, we're going to talk about that. The equation of a line, you're going to write in slope-intercept form. So when I say that, do we understand what that means, slope-intercept form? Okay, so it's what? Okay, good. Y equals mx plus b. So we're going to do that. First, we're going to talk about what is a tangent line. So I'm asking you to write out your definition and then show an example of a tangent line using a picture from your textbook. So we're going to look at that now. So your definition of a tangent line to a curve y equals f of x at the point p a comma f of a is the line through p with the slope. Now when it says the point a f of a, remember a is just your x value or your input, and f of a is the y value or your output. So when you plug in a into f of a, that's going to be your y value, the second part of your point. Now, we were talking about limits this week. So the limit as x goes to a of f of x minus f of a over x minus a. If I covered this part up, does that equation look familiar? It is the slope. Do you guys remember when we talked about that? We did this exact equation. It was for the rate of change, okay, in section 2.4, and the equation looked just like this. What we had to do is plug in your x value to find your f of x, your a value to find your f of a. And really, your slope is just the rate of change. It's the change in y over your change of x. Now, we're adding the limit here, so that way, if we do have something that is undefined, we can still find that number that the graph is what? Anytime you're finding a limit, you're finding the number what? It approaches. Abby? Okay, so what the picture that I'm going to have you draw is this one here, okay? So we're going to be finding the tangent line at a point, and that's going to stem from this picture with our slope, okay? All right, so I'm going to just go over what this looks like here. If you're watching this video, they're laughing because they think it looks like okay, so if you have your point P and your point Q, okay, this is your input, this is your output, this is your input, this is your output. This is exactly where your equation comes from. So your A value is somewhere on the x-axis. Your x value is somewhere on the x-axis. This is just your rise over your run, okay? So the run part is your x minus a. This is your x sub 2 minus your x sub 1. You have the f of x and the f of a as your outputs, which is your rise. So your f of x minus f of a. And that's where this equation comes from. So it is equivalent to the slope. I don't know if you guys remember, but when we studied the rate of change, if you had a linear function, we would solve it algebraically, but we could check, because if it's a linear function, what can you see? The slope, right? So if it's a linear function, if it's y equals mx plus b, can't you look at the equation and pick out your time right away? Yeah, so those should be the same value, okay? And we'll actually explore that a little bit again today. Okay, so we're going to have this picture, and then we're going to have this definition of your tangent line. Now, if you look at the picture next to it, you can see that if it's tangent to a line at a certain point, this is going to be the equation of the line that we are finding. Okay, and here, no, you don't have to. I don't want you to, I don't want it to be too complicated. That's page 858. So this one is also similar. They are just showing you here your tangent line, which is in red. And you're going to have two equations today. So we're going to go over them. This is going to explain to you the second equation. So today we're going to find the tangent lines of curves, and we're going to use limits to do this. So in order to find the equation of the line, we have to know what the slope is. Okay? And there are two different ways that you can find the slope. So you have to use one of these two equations. So either the limit as x goes to a of f of x minus f of a over x minus a, or the limit as h goes to 0, and that's f of a plus h minus f of a over h. Now that formula should actually look familiar too. You guys remember towards the beginning of the year we did substitute those in and we simplified? Do you guys remember what happened at the end of most of those problems? Okay, yeah, you were able to factor out the h and then they would cancel, which yesterday for your homework, remember how we were simplifying some of those? And a lot of times, couldn't we factor? Yeah. We could factor and we could simplify. This will be very similar to that. Okay, now for many cases, you can use either one of those. Okay, so you can use either one of those equations. In some cases, one is going to be easier than the other, and we're going to explore those together today. So for example 1, you're going to find the slope of the tangent line to the graph of f at the given point. Now, whenever you are given a point, I'm going to show you how to label it. Okay, so your point is going to be your a value and your f of a value. Okay, so your a value and your f of a value. Okay, and then for this one, I'm going to show you how to do this with the second formula. If you finish that one quicker than I do the other one as well. Okay, so I'm just going to write down the formula first, and then Abby will get your question in just a second. So the limit is h goes to 0 of f of a plus h minus f of a over h. Okay, Abby, go ahead.
Why do you have to use more?
Well, it's not that you have to, it's just that they're going to be useful. So the limit, finding the limit at a certain point, like with this one, if you plug in 0, right, you wouldn't have a valid answer. Okay, you would get something that's undefined. So if you're using the limit, it takes out that undefined piece, and you can see what's happening as you get closer and closer to it. Okay, so what we're going to do now is we're going to substitute in our values. See how my a value is 3? Okay, so wherever there's an a, I want you to plug in 3. Can you guys do that? Wherever there's an a, you're going to plug in 3? Because some of your writing utensils are not moving. You know, wherever there's an a, you're plugging in 3. Okay, so this is a plus h. So what am I replacing a with? 3. So 3 plus h. Now, this is f of a. I can replace f of a with what? 6. Good. Okay, now let's think about what f of 3 plus h means. If I just had f of 3, okay, Jesse, how would I find f of 3?
I don't know.
So f of
0, 3.
if you're just doing f of 3. If I just gave you, if you know f of x is 2x, and you're trying to find f of 3, what would that be?
Put 3 in for x.
Yeah, wouldn't f of 3 just be 2 times 3? Yeah, okay, so this is very similar, except I'm doing f of 3 plus h. So what am I plugging in for x? 3 plus h. Okay, so if it's just f of 3, I replace it with 3. So if it's f plus h, or 3 plus h, I replace it with 3 plus h. So for my next step, and notice that I am writing my limit for every step here. If it's 2 times x, I'm going to do 2 times 3 plus h. I still have my minus 6. I still have my h here. And then I can simplify. Okay, so the limit as h goes to 0, 2 times 3 will be 6. 2 times h will be 2h minus 6. Okay, can we see what's going to happen in the numerator? Yeah, Diddy, what's going to happen?
Wait, did you say minus?
Uh-huh.
Yeah, well, 6 is what cancel out and the 8 is what.
Okay, good. So 6 minus 6 will be 0, so I'll have 2h over h. And what's going to happen with my h's? Okay, those are going to cancel out. So it'll be the limit as h goes to 0 of 2. And now I can take the limit. So I can't skip this step, because if I plugged in 0 here, what would happen? What would happen if I had 0 in at this step? Be undefined. Okay, so I have to show that it's 2. Well, if I'm plugging in 0, is there any place to substitute it into? No, so then my slope is going to be what? 2. Okay, so you have to show me how you're finding that algebraically. Can I check this with my equation? Yeah, okay, so this is a linear equation. So what's the slope of my equation? Your slope is what?
2.
Okay, your slope is going to be 2. Okay, so if it's linear, right, it's pretty easy to find out what the tangent line is because it's going to be straight. So of course, we're not just going to have linear functions. Okay, we might have f of x equals x squared plus 2x at a given point. Okay, so again, we can label this as our a and our f of a. And then I want you to go ahead and see if you can substitute in your correct values. And I'm going to write out the equation again. And then if you want to, once you're done with this, because I know some of you are working ahead, once you're done with this, go ahead and try this with the other equation. Okay, so go ahead and do your substitutions.
I don't know who it is.
Okay, so I'm giving you the formula, and then you're going to substitute. Okay, so how many of you are finished finding it with this method? Okay, so your slope The limit as h approaches 0 is going to be f of negative 3 plus h minus your f of a, which is 3, over h. So this will be the limit as h goes to 0. Now when I plug in negative 3 plus h into my equation, I'm going to have negative 3 plus h squared plus 2 times negative 3 plus h, and then that value minus 3 all over h. Okay, were you guys able to do your substitution correctly? Uh-huh.
I thought, isn't just f of a 3? So wouldn't it be like negative 3 plus h squared plus 3?
Your f of a is 3, so because your formula is minus, you'll have minus 3.
Right, but you have like all this other stuff with
Well, you need your f of negative 3 plus h first.
oh, I see.
Yeah, so the second part is just minus 3, and the first part is substituting in for x. So if I do negative 3 plus h squared, I have to FOIL. If I FOIL, I should get 9 minus 6h plus h squared, which is what we talked about in our bell work. Distribute, 2 times negative 3 is negative 6, 2 times h is 2h, minus 3 over h. Then I'm just going to clean it up. So what I mean by that is I'm going to combine all my like terms. Once I do that, I have h squared minus 4h over h. What am I going to do? Lauren, what do you think? What am I going to do here?
I took the h squared divided by h, so you got the h and
Okay, yeah, so you can divide both terms by h, okay, or you can factor out the h, and then they will cancel. So then you'll have your limit as h goes to 0 of h minus 4. Now can I plug in my 0? Yeah, so once you can plug in your 0, that's when you drop the limit. Notice that every single step in my process has the limit except for the last step when I plug it in. Okay, so then your slope of the tangent line for this is going to be negative 4. Yep, and then I'm also going to show you the other method. Okay, so this is for if you're using the limit as h goes to 0. How many of you tried the other methods? Okay, good. Now, really, for part A, I actually think the other method is a little bit quicker, so let's look at those. We're going to kind of look at them side by side. Okay, so for part A, if you wanted to use this formula as x goes to a of f of x minus f of a over x minus a, what you could do is you could substitute in x. Well, f of x is just going to be 2x, so that goes here. If you plug in a, this will be 2 times a, so 2a. What can I do with 2x and minus 2a? What's the same in both of them? 2, so I can factor, and then look what's going to happen. Yeah, you have the same factor on the top and the bottom, so this will be the limit as x goes to a of 2, which is just 2, and really you can replace a with what? Yeah, really here I would start to replace a with 3. So this would be the limit as x goes to 3. This would be the limit as x goes to 3. For this one it didn't matter because you get a constant, so it doesn't matter what value you approach, you're always going to get 2. Okay, so you could choose which one you want to use for this. You don't have to use this one, okay, but you can use this one. Now, the reason why I'm going through this with you for 2 reasons. 1, sometimes it is more challenging, so it's good for you to see that. 2, you can always use this, and you'll never run into any trouble. Sometimes when you use this one, you might run into some trouble, and I'll show you when that happens. Yeah, Logan?
At the very start when you were showing us that, the f of x minus f of a over x minus a, I thought, isn't f of a given a value of 6 for that problem?
Okay, yep, and then so you could do that also.
Yeah, because you just plugged in the a for the f of x instead of putting the 6 in
Right. Yep. Exactly. Yep. So for that, because those canceled out, I was able to do that. So that's what I did. And then, like you said, you can also plug in the numerical values, which is what I did for B. So I'll show you that. Okay. So for B, if you use the same equation, f of x is your given equation. You have a squared plus 2a. See how these aren't going to cancel out? See how nothing's going to cancel out on the top? Okay, so that's why you'd want to plug in these values. So for f of a, let's just substitute in 3. So instead of minus this value, we're just going to do minus 3. And then for a, I can plug in negative 3. So if I plug in negative 3, any place there's an a, right? X minus negative 3 will be x plus 3. You could end up factoring this. And once you factor, you'll have a common factor. This will be the limit as x approaches negative 3 of x minus 1. And so now I can substitute in negative 3, and I'll get negative 4, which again is exactly what we got in part B. Okay, so you could do those either way. What other questions do you guys have for me on those? Okay, so it's not like the process is difficult. It's just there are lots of steps you have to write out because you're solving it by algebra. Okay. All right, let's look at the backside. And the backside should look familiar because when did you see it? You saw this yesterday, right? Okay, so this was the page that was accidentally in your notes yesterday. So for example 2, we're going to find the equation of the tangent line to the curve at the given point. And then we're going to graph the curve and the tangent line. So this is our equation, and then it gives us our point. Okay, our point is 1, 4. So just like we did before, we can go ahead and label that point. The 1 and 4 is going to be, Celia, what values are those going to represent? Yeah, your A and your F of A. Okay, so this is your A, this is your F of A. Now we're going to use this equation. Don't use the other one. I'm going to show you why not. For time constraints, I'm not going to let you suffer through and try to find out why not. I'm just going to show you. Okay, so we're going to use the limit as h goes to 0. If this is my a, okay, my a plus h is going to be 1 plus h. And then instead of minus f of a, I'm going to be plugging in 4, and then that's over h. Okay, so again, you do have your two limit formulas. I'll just put this up here as a reminder. So it's f of a plus h minus f of a over h. Okay, now, you could have tried to use the other formula. Let me just show you what happens. If you did that, once you plugged everything in, you would end up with x cubed minus 2x plus 1. Can you factor x cubed minus 2x plus 1? No, you could if it was x squared, but it's not. It's x cubed. The reason why you won't be able to factor that is because there are going to be imaginary zeros. Okay, so yeah, so you don't want to do this. So we're going to use the limit as h goes to 0 equation. Okay, so now what we're going to do is substitute. Okay, so this is the limit as h goes to 0. So if I plug this in, it's 1 plus h cubed minus 2 times 1 plus h plus 5. And then I still have the minus 4 here, all over h. So now you can see why I made you do the bed work. Because what do we have to simplify? Yeah, the 1 plus h cubed. Okay, so I'm going to give you a minute to solve that how you want. So if you want to FOIL it out, go ahead and do it. If you want to use Pascal's triangle, go ahead and do it. What I usually do is here. I need the limit. Okay, what I usually do is I'll just like write this off to the side and do my work there. What's going to be faster, Pascals or the expansion? Pascals. Yeah, Pascals. But it's a 1.
You did it too, that's awesome. Answer the question. We did it, we talked about it for a little bit. Yeah, so we never did it again.
You don't have to do that.
I just looked at our homework too, because we looked at that one.
Okay, so once you simplify, you're going to plug that in, okay? And really multiplying the first step should be pretty quick for you, right? You're squaring the 1, you're doubling 1 times h, okay? And then h squared, which Mr. McKinney always had a cool saying for that. It's like square, double, square. I'll have to ask him.
Sounds helpful.
There was. Okay, so then this is what I got. So if you multiplied it out like this, you would have something similar. And then remember I said I like to line those up so it makes it easy when I go down. But if you do use Pascal's triangle, look. 1, 3, 3, 1. See how the h is second? So h to the 0, h to the first, h to the second, h to the third. Okay? So here I have -2, so I'm going to distribute that. -2 times 1 is -2. -2 times h is -2h. And then I just simplified. What's 5 minus 4? 1. So now I have to clean it up. So I'm going to combine all my like terms together. Do I have any cube terms? Yep, I have 1. Okay, so h cubed is going to go on my next step. My h squared terms, I only have 1 of those. I have 3h minus 2h, which is going to give me an h. And then I have 1 minus 2 plus 1. What's that? 0. Okay, so I'm going to write down my simplified expression. Bless you. I'm going to factor out my h. Now, remember we said earlier about how when we did this at the beginning of the year, the h is factored out. We were able to cancel them. All that good stuff. When you write this out on your test or your quiz, you're going to have to make sure that all of your steps are correct. And what I mean by that is sometimes if you look at somebody's numbers, like I can see 1 plus 1 minus 2 is going to be 0. It's going to cancel out. Sometimes people will forget to distribute. So depending on the order, if they had like plus 2, they'd have 1 plus 2 plus 1. But because they know the pattern, they would just write it so that it canceled out. If you don't have all of your steps that are mathematically correct, then you won't get full credit for that. So you have to make sure that you distribute properly. Okay? All right, and then so once the h's cancel out, you have h squared plus 3h plus 1. Now you can substitute in 0. If you substitute in 0, 0 squared plus 3 times 0 plus 1 is going to be 1. That's going to be your slope. So now we're going to find the equation of the line. So to find the equation of the line, there's 2 equations that you can use, either y equals mx plus b, or you can use the point slope formula and then simplify. Okay, so here are those 2 equations. You can choose which one you want to use. But we know that our slope, which we just found is 1, we were given the point 1, 4, so that's going to be our x1, y1. So then you're just going to substitute that into the point slope. I like to use the point slope. In the next one, I'll show you how you can use the other formula. So if you distributed the 1, you're still going to just have 1x minus 1. So I'm going to add 4 to both sides. So negative 1 plus 4 is 3. So 1x is just x, so y equals x plus 3. So now we're going to graph that. Okay. When you are graphing, if it's a line, you're always going to start at what? Your what? Where are you always going to start when you're graphing a line? Where do you guys always start when you're graphing a line? Yeah, the y-intercept, right? Okay, so you can start at your y-intercept, which is 3, and then if your slope is 1, you're going to go up 1 over 1. Okay, up 1 over 1. For your other graph, I am perfectly fine if you want to use your graphing calculator to find your values. Minus 2x plus 5. Okay, and then your table set, it might be a little funky from what we were doing before, so I'm going to go back to 0 and 1. I'm going to go to my table. I'm going to see at 0 I'm at 5, at 1 I'm at 4, at 2 I'm at 9, at negative 1 I'm at 6, at negative 2 I'm at 1, at negative 3 I'm at negative 16. So I'm just going to plot some of those points. What's that? Your original equation. Because when you graph the line, that one you can do without it. Okay, and then I went by 2's on my scale just so I could get up to values that were past 5. So this was 10, this was negative 10, and then on my x-axis I went by 1's. Okay, so at negative 2 I'm at 1. Okay, bless you. At negative 1 I am at 6, so 2, 4, 6. At 0 I'm at 5. 1 I'm at 4. 2 I'm at 9. Okay. Now, remember when we were talking about end behavior?
Yeah.
So this is an odd function, so the ends are going to do what?
Going opposite direction.
Yep, go in opposite directions. And then if it's a positive coefficient, it's going
Up on the right.
up on the right. Okay, so this is just going to curve through here. Okay, so I'm going to curve this. What was, negative 3 was negative 16, so it'll be off. Yeah, your original equation from the problem. And then we're going to graph the tangent line. Okay, so the tangent line is going to start at 3, and then the slope is 1. So I'm going to go up 1 over 1. Up 1 over 1. And really, once you see where it hits it, you can just use your straight edge. So this is what we just found. Actually, I'll do that in a different color. Okay, so this is your tangent line T. See how it hits it in one point? Oh yeah, it does. So this part here is where it's tangent. So at that point, it's gonna hit it. And that point where it hits it is what? 1, 4. Is that special? Yeah, it's where it's tangent, right? Okay, good. All right, let's try part B. So, yeah, question?
Can we really quick go back to step 1 for that, like at the very end? Because I messed up somewhere.
Okay, I'll come help you.
Oh, okay.
Okay, so let's do part B. Okay, so for part B, really you can use either equation you want for part B. What's that? Oh yeah, sorry. For B, this should have been given to you. This is at 4-1. Okay, and then for C, this is at 3-2. Let's actually, for B, we'll do this together and we'll use this. So the M equals, the limit is H goes to 0 of F of 1 plus H. Or sorry, in this case it'll be something different. So you have A, your F of A. Okay, so see if you can fill that part in. So just do steps 1 and 2, and then I'll do the rest of it. Okay, so let's see how we did at plugging this in. So you should have F of 4 plus H minus 1 over H. Okay, and then we should be able to do the next step as well. So the limit as H goes to 0, and this would be of 4 over, and this is where you're plugging in the 4 plus H minus 1. And then it's still divided by H. This is like what we did yesterday. Remember yesterday, if you had this situation, if the denominator was 0, what did we try to do with the rest of it? We tried to simplify it in some way, right? Didn't we have lots of different ways that we could simplify? We did rationalizing, we did factoring, okay? So to simplify this, let's try to get rid of this fraction. If you want to make a fraction into a whole number, okay, then what do you multiply by? Say again? The denominator, okay? So we're going to multiply by the denominator. So the denominator of this fraction is 4 plus H. Now, when you multiply that, see how you have 2 terms here? That means you have to distribute. So you're going to distribute to this term, and you're going to distribute to this term. Okay? So when you do that, it's really like you have the limit of H goes to 0 of 4 over 4 plus H times 4 plus H minus 1 times 4 plus H. And then remember yesterday how we just left this as H times 4 plus H? We're going to do that again today. Okay, so now because this is in the numerator, this is like over 1, those are going to cancel. So I'm going to be left with 4, and then now I'm going to distribute negative 4 minus H. So make sure you distribute the negative. I'm going to keep the denominator the same. Okay, so 4 minus 4 is going to be 0, so I have negative h on top. H times 4 plus h on the bottom, what's going to happen? Yeah, what'd you say, Olivia? Yeah, the h's are going to cancel. So now, because this is a negative, I'll have negative 1 on top. I'll have 4 plus h on the bottom. Now can I substitute in 0 and get a valid answer? Yes. So this will be 4 plus 0. So this would be negative 1 over 4. Okay, so then for step 2, you're going to find the equation of the line. And like I said, you can decide how you want to do that. You can use your slope as negative 1/4 and your point is 4, 1. Do you guys want a reminder on how to do it with the mx plus b? So like this is your x, this is your y. So 1 equals negative 1/4 times x plus b. You would solve this for b. What's negative 1/4 times 4? Negative 1. So then solve for b. B would be 2. So your equation would be y equals your slope, which is negative 1/4, x plus 2, which is now your b value or your y-intercept. Okay, for sake of time, I'm just gonna show you the graph. Again, what I expect you to do is to use your table on your graphing calculator to pick out a few points that are on your graph. Okay, and then you're just going to connect with a curve, and you can check that in your graphing calculator, and then you're also going to plot your tangent line, and your tangent line, if it's plus 2, you're going to start at 2, and then you can go down 1 over 4. You can go up 1 over 4, and then you're just going to connect that with a straight edge. Okay, so I'll have you finish that later just for sake of time. For C, f of x equals the square root of x plus 1 at 3, 2. So this is your a and your f of a. This will be the limit as h goes to 0. And then f of a plus h is going to be 3 plus h minus f of a, which is 2, over our h value. Are you guys starting to get pretty comfortable with the substitution here?
Yep.
So all you're going to do is replace 3 plus h into your original equation. So in my original, I have the square root of x plus 1. So this is 3 plus h plus 1. And I am going to simplify that. And by simplify, I mean I'm just going to add the 3 and the 1 together, and this is going to be the square root of h plus 4. Can you break that apart into the square root of h plus the square root of 4, which would be 2? No, that's an expression that's stuck together. You can only separate if you have multiplication. Okay? If you don't believe me, if h was 5, 5 plus 4 is 9, the square root of 9 is 3, okay? So is the square root of 5 plus the square root of 4 going to be 3? No. No. The square root of 4 is 2. The square root of 5 is not going to be 1. Okay, so they're not going to be equal. Okay, so we did this yesterday. What did we do if we had a radical on the top? Multiply by the conjugate. Yes, okay, good. So then we're going to rationalize. And I'll tell you the part that I forget when I do things like this is I forget to multiply the bottom. So we have to make sure that we're doing that. So this is the limit as h goes to 0. The square root of h plus 4 times the square root of h plus 4 is what? h plus 4. And then the middle will cancel out because they're opposites. Negative 2 times 2 is negative 4. And then on the bottom, it's h multiplied by h plus 4 plus 2. Okay, so don't forget that that's still part of your equation. Okay, now we're going to write out each step, which I know some of you are not going to like. I'm sorry. You'll do this next year in calculus as well. Okay, and then in the next step, you can go ahead and simplify because you know that your h's are going to make what? Really, yeah, they're just going to divide to 1. Yeah. Okay, so then it'd be 1 over the square root of h plus 4 plus 2. Now can I plug in 0 and get a valid answer? Yeah. Okay, so then we're just going to write this down real quick. 0 plus 4 would be root 4 plus 2. So it would be 1 over 2 plus 2, which is going to be 1 4. I'll post the rest of this online. That's why I'm just going to keep talking. Okay, so once you get 1/4, that's going to be your slope. Okay, so for step 2, your slope is 1/4. Your point is 3, 2. So I'm going to use the point slope formula. So y minus y1, which is 2, equals your slope, and then x minus 3. So we're going to distribute 1/4 x. This would be negative 3/4 plus 2. So y would be 1/4 x. If I do 2 minus 3/4, that's 1 and 1/4, 1.25, or 5/4, which is what I would prefer, is the 5/4. Okay, and then we're going to go ahead and do our graph. Okay, so from our graph, again, we're going to use our calculator to generate some points. Here we're going to start at 5 1/4, so 1 1/4 is just going to be a little bit above here, and then I'm going up 1 over 4. Okay, up 1 over 4. You could also go down 1 and over 4. All right, and then your homework is going to be 3 through 6, 8 through 10, 13, and 14.